Hi, it's Chris Brown here. I'm the technical lead on the ParaFormance project, and I'm going to give you a short demonstration today of some of the features of our toolchain. So what I've got here is I've set up a standard IDE for C++ program development. This is Eclipse. This is just a standard C++ IDE that's commonplace throughout the market. Where my mouse is here in the center of the screen, this is the code view. So this is where programmers typically write their applications, write their code. As you can see here, I've got some code I've already set up that I pre-prepared, some examples. And on the left-hand side here, I've set up some applications. So here, these are just different applications, kind of small demonstrable applications that demonstrate different parts of the features of our tool set. And this one in particular is called a Mandelbrot example. So here on the left you can see there are various files here associated with this example, and I can build this project here. So this is currently a sequential application. There's no multi-core code in this application whatsoever. It's not geared to run in parallel or on a multi-core device, purely on a single core machine. And I can build this device, this application. So I just first do that. I go to Project, Build Project. So ParaFormance uses the compilers that developers already use in their tool set. It doesn't need any specific kind of compilation build process. It integrates seamlessly into a normal development process. So all I've done there is I built the program, and I'm going to now execute it. And at this point, I haven't actually ran any of the ParaFormance tools on the application yet. I'm merely just showing you the original version of the application that hasn't been changed in any way. As you can see down here, it's actually finished. So it says the time that it's taken to execute has been about 8.5 seconds. So this is 8.5 seconds on a single core. There's no parallelism in this yet. And if I go to the left-hand side here, I can see down here, it's produced this file. So you can see this quite pretty looking fractal image. So this piece of C++ code, this Mandelbrot example, has generated this Mandelbrot PNG file. So it took 8.5 seconds for it to generate that image. Okay, so if I go back to my code here, and I want to make this parallel. So I want to make this run on a multi-core device, and I'm going to use the ParaFormance toolkit to do that. Well, firstly, I need to know where in my application I'm going to actually introduce all the parallel business code. So that's the first step, and ParaFormance allows me to do that. So we have a feature here called parallelism detection. So this is the feature called discovery. And it searches all the points in the application and does a very detailed analysis on it to determine where the parallelism should go, what kind of parallelism should be inserted, the benefits that it will give, etc. At the moment we've only prototyped this feature, so I can only show you the principle of what it can do. So if I run that, as you can see here, the idea is it selects parts of the program, and then we will extend this shortly to give some advice to the programmer to say what you should do with this highlighted piece of code. So you should make this parallel by following these steps in order to achieve it. But we're still under development for that feature at the moment. So I'm just going to clear that, and we're going to assume just for the moment that the tool has come back. I've run the discovery process. It's come back and said, this piece of code that I've just highlighted, this should be parallel, and it's told me how I should do it, what kind of parallelism should be achieved, should be inserted, etc. So once I have that information, I can go to the ParaFormance menu. So this menu is integrated into Eclipse. It's not a standalone tool. It's seamlessly integrated into the build environment. You look at that menu here, there's lots of options I can perform. Generally, it's divided up into different types of parallel libraries. So the most common ones typically are things like OpenMP, Intel's TBB, that's the thread building blocks library, and so on. The FF is another one called fast flow. So these are just examples that we've built in to our tool just to demonstrate that we can integrate different types of libraries that exist on the market at the moment. So just as an example here, I'm just going to pick TBB, and we've also divided up not only the different types of libraries, but different types of patterns within those libraries. So for example, in TBB, you can have things called parallel maps. You can also have pipelines. If we look at fast flow, for example, they have a thing called a farm. So these are like design patterns, high-level design patterns for multi-core programming. And all these types of different parallel libraries come with these design patterns built into them. And part of our ParaFormance philosophy is to use these high-level design patterns as part of our process of making applications multi-core. So assuming that we have these design patterns and we have these libraries, we can then choose what type of pattern and what library to use to make our application multi-core. So this example, I'm just going to use TBB and I'm going to make it a map, just as an example. What I have to do is click on that. Then it comes up with a dialog box. So if I know a little bit more about C++, I know a little bit more about the application, I can change the defaults that ParaFormance is offering me. Of course, if I'm a non-specialist programmer, I don't know anything really about the goals that I'm achieving, I can trust the tool to do its job properly, and I can just go with the defaults. So if we've got some options down here, I can cancel the operation, so I can just cancel, so nothing is committed. If I go back again, I can preview, or I can just go straight to committing. But as an example, I'm just going to preview first. As you can see here, before ParaFormance has allowed me to continue, it's said that it's found a problem. So it's done a safety check on the code, and it's found a problem. The problem is on line 65 in the file mandel.cpp, and it's telling me that there's a potential data race on the variable k. So a data race is a type of concurrency error, and the ParaFormance tool is able to check these types of errors up front before the code is even made into a parallel application. It can tell me whether or not there are going to be problems, whether there are going to be bugs. So assuming I'm just going to ignore the tool for the moment because I'm a specialist programmer, I think I know better. The tool will never stop me from doing something. So I can just click continue. We get the preview pane as I described before. The left-hand side shows the original application. This is the untouched application here. The right-hand side shows the new application after the ParaFormance refactoring has been applied. And we can see here at each line number on the right-hand side the different code that will be inserted into the application. If I scroll down, so this on the left-hand side, this was the loop that I selected. On the right-hand side, it's going to transform that loop into a TBB map design pattern. So it's going to call various methods within the TBB library that allow the parallel map pattern to be instantiated. So it's going to make this sequential version into a multi-core version on the right-hand side. And if I'm happy inspecting this preview, I can click OK. ParaFormance goes ahead and modifies the application. So this is now a multi-core application. So all I've had to do is click one button. I've gone from a sequential version to a multi-core version almost immediately. So now if we run this, let's see what happens. So I have to build it again. And I execute it. And you remember there was a problem came up. So ParaFormance told me that there was going to be a potential problem with this application if I tried to make it multi-core. So let's see what happens. So it's finished. It's much quicker. It's taken 3.5 seconds against the original 8.5 seconds. So it's definitely running in parallel. I see performance gains. If we look at the output, you can see it's completely broken. It doesn't work at all. And this is because I ignored that problem that the tool showed me. So if you can imagine you're a high-frequency trader, you've got hundreds of thousands of lines of code, probably millions of lines of code. You try and make it parallel. The problem with that is there are going to be many issues with it. So trying to do that yourself, trying to do it manually, finding all these issues, is going to be almost impossible. And then the second problem is, even if you found the issues, inserting all the code to make it multi-core is again another challenge on top of that. So what ParaFormance does is it's a full tool chain. So it goes from sequential code to a multi-core version through all the steps required. First step is it tells you where the parallelism goes. Second step, it does a safety check to tell you that there are going to be any problems or not if you make it parallel. Third step, you make it parallel. So that's what I've shown you here. There are also a couple more steps I'm going to just introduce. The next step is that I can always go back to the sequential version. I can always undo. I can go back to a sequential version. This example, I can fix it. So ParaFormance will tell me how to fix it. It will give me advice on how to do that. At the moment, it doesn't, but you can imagine that it's told me how to fix this program. Assuming it's done that, I can go back and parallelize it again. This time I'm going to bypass the preview. Just click OK. I need to build the project again. And I'm going to run it. And it's produced as PNG. And it's fixed it. So it's now, the PNG is correct. The fractal is correct. It's because I fixed the problem with it. We can also do other kinds of analysis on code. So assuming that we've already parallelized our application using ParaFormance, we can then do a much more detailed safety analysis on the code. So this example, this is another example I've made. In this example, I've already used ParaFormance to parallelize the application, but now I want to just check that it's still safe to execute. So this could be, I could have modified the code, I could have extended it in some way, and I want to check that it's still okay if I execute this. What we've got is a concurrency safety check, which I can run at any time, before or after the ParaFormance multi-core insertion part. So I'm just going to run it after, just to see if there are going to be any errors in this application. This analysis takes a bit longer to perform because it's doing a very detailed check. As you can see here, if I go down to the Eclipse pane problems, it's come up in just this very small application. I mean, this is only a couple of hundred lines of code in this application. It's already come up with quite a few different errors. So we've got a number of warnings here. These are all errors that ParaFormance has flagged. For example, here we've got a possible race condition here, another one here. These are possible race conditions, etc. So once I've got this information, then I can then inspect that problem pane. ParaFormance will give me some advice on how to fix it. I can then fix it, run the safety check again, and ensure that my application is safe and correct for multi-core execution. So, thank you very much.